All right, what is up, chemistry people? Today, we are going to design and or interpret the results of an experiment involving a redox titration. So similar idea as your acid-base titration, except instead of a neutralization reaction, we're talking about a redox reaction that has a hopefully pretty nice color change. All right, so let's break that down a little bit. Basically, you're going to have to remember how to balance redox reactions using that half reaction method. So splitting things up into their oxidation reduction half reaction and then balancing the two. And then once you've balanced your redox reaction, you're going to have to do some stoichiometry, that's never going away, and apply them to those redox titrations. All right, so just a couple of quick notes here. First of all, a redox titration, what the heck is it? It's a volumetric method that relies on the oxidation of the analyte, or the things that you're analyzing, trying to figure out. Very similar to what's happening in an acid-base titration, in as much as it's sort of a volumetric analysis, although in the acid-base titration, we're focused on the change in pH. Keep in mind that the titrant of a solution in your redox titration is often an oxidizing agent. Keep in mind that means itself is being reduced. And that when you perform a redox titration, you're going to be looking for a well-defined color change to let you know that you've reached the equivalence point. And if you don't have that color change, sometimes you have to use an indicator to let us know when that equivalence point has been reached. And again, there are a couple different types of titrations. We've done acid-base titrations already, but a redox titration curve is going to plot the electrode potential, or your voltage, versus the volume of titrant, which is not to be confused with an acid-base titration, which we just did. Still volumetric in nature, but remember, the acid-base titration, we are plotting pH versus volume. But as you take a look at a titration curve for an acid-base titration versus the titration curve for a redox titration, again, you're looking for that equivalence point so that you can determine the stoichiometric relationship that exists between your two reactants.